All right, so what we're going to do is we're going to explore the concept of a linear relation, okay, and a quadratic in the end, and how we're going to see if something is quadratic or something is a linear relation, okay? Now, here's what you know about, here's like three different graphs with linear relations, right? Well, with linear relations, you have a positive, you have a negative slope, a positive slope, and a negative slope. Each of them have intercepts. Each of them have an intercept. Each of them have a slope, which is the rise over the run, also known as y2 minus y1 over x2 minus x1. And the basic equation is given by this. Y is equal to mx plus b. So those are some basic things, right? The other thing that you should put on here is that they form a straight line. And then 5, they always go up by the same number of steps. Or let's say instead of up, let's say up or down by the same number of steps. All right. So now let's continue with this lesson. So imagine that we're looking at these three basic equations. I'm just going to zoom in on these. Okay, so you have the following. Y is equal to negative 1/2 x to the 4. Okay, you also have y is equal to x minus 3 and y is equal to negative x. Now, if we wanted to know what is common between all these three linear relations, this is it. One of you during one of the lessons that we were doing mentioned this to me. There is only an x in all of them. So there's only an x in all the equations. So we have something that looks like this. Y is equal to some bracket of x plus some constant. And the key is there is nothing. It's just an x. The key is when we have a linear relation, anytime we see a linear relation, there's only an x. There's nothing else. There's an x and a couple of numbers, and that's about it. Okay? Now, let's go and take a look at something that I alluded to earlier in the course, but we didn't have time to go over it because, well, this is an online course and we don't have much time. So, what is about the table of values of a linear relation? So remember, we said earlier that it always goes up or down by the same number of steps. Okay. So what that means is when we have a table of values, all we have to do is take a look at the y values. So let's call this example A. This is example B. Oops. Example B. And then this is example C. So what we're going to do is we're going to go and investigate whether these things are linear or not, and I will show you how I want you to write the solutions out for something like this. So let's take a look at example A. I'm just going to copy this down, and then we will do our problems together. All right, so I'll move that up. I'll click on this, move it up. All right. So there's example A, example B, and example C. So let's see if this is linear. So in math, we call this the first differences solution for a line. So here's what we're going to do. The key idea is to actually subtract the bottom minus the top. So remember, you're always subtracting bottom number minus the top number. Okay, so now in this case, I've got 4 minus 6, which gives us -2. Use your calculator. And then you go 2 minus 4 gives us -2. And then 0 minus 2, punch that in your calculator, you end up with -2. So this is what we call the first difference. And we call this the first differences because if the first differences are the same, we know that this thing is, since, you could say, since the first differences are the same, let's go diffs are the same, then this is linear. So it forms a line. Remember we said at the beginning, when we had a line, it always went up or down by the same number of steps, and that's what our first differences go and tell us. So pause this video, copy this down, then we'll do example B and example C. Okay, so now let's go and do example B and example C. So I'm just going to delete all this stuff, right? Because, you know, it's useful. Get rid of, I'm going to ungroup, delete this. And now let's go and do example B. Example B is going to be done exactly the same. Okay? Example B will be done exactly the same. So we're just going to copy that down and we're going to do our problem. So let's see if it is linear, right? If these things are linear, then what we have to do is we have to find the first differences, and we need to remember that we're always and so now what happens is we subtract the bottom from the top and we go -3 minus -4, and you'll notice that I put a bracket around -4, and that reminds me that I have to punch that in properly on my calculator, which gives us 1. Okay, I think. And then we go -2 minus -3 gives us 1. And you'll notice I put the -3 in brackets. Please remember that. Okay, the brackets are always very important. Okay, always. You'll notice we've got brackets here. Okay, so we got to use those brackets in order to do the appropriate calculation. So now we can say, since the basically first differences are the same, then this is linear. That's it. So now once we get to the end of me writing this, what I'd like you to do is I'd like you to pause the video and then copy example B. And that's it. Thanks. And so now let's move on to part C. Same thing, but this time you're gonna pause me, try it, and see if you come up with the same numbers as me. All right. So now let's go and clean this up, get rid of some of this stuff, and start our new problem. So now we're going to go and take a look at example C. All right, so pause the video and check to see if this is linear. Okay, so here we go. So now, remember, it's always bottom minus top to test to see if something is linear. So now let's do this. So we got 3 minus 4 gives us -1. 2 minus 3 gives us -1. And 1 minus 2 gives us -1. Okay, and remember, these are our first differences. Make sure that you identify this on your sheet. The reason why we need to do this is because I need you to identify the concept of our first difference. So your first differences are the same. So you'd say, since the first diffs are the same, This is linear. And we're done. That's it. Okay. Pause the video, copy this down, and make sure that you're ready for the next bit. All right. So what is it about a quadratic relation that makes you sure it's a quadratic? So let me explain to you why it is. For these graphs, each of these graphs look very similar, right? You have one that's opening down, one that kind of goes up and then goes back down, and one that goes down and goes back up, and one that goes down, up, and then goes back down, right? When you think of these quadratic relations, we have literally this point here, and this point here, and this point here. I call that the V, right? You're going to know this as a quadratic relation graphically has a vertex at either its highest point or lowest point. Okay, we'll get into that a little later, but right now we're going to focus on things like graphing those points and then also looking at the tables of those points. So just like we did when we were taking a look at lines, right? So when we had a line, when we did our first differences, we got the same first difference for everything if it was linear. For quadratic, we got something a little different. So let's see and express what the heck is going on. So overall, let's just finish this. We said graphically, there's a vertex at either the highest point or at the lowest point. So these, I'm putting vertex. Yeah, and basically we just identify those things as the vertex. Now, remember I said it was the highest point or the lowest point on our graph, right? Now, every time you're looking at a parabola, either it opens up or it opens down. Or down. Now, you can always find x-intercepts and you can always find y-intercepts, and we'll take a look at that later. All right, so right now we're focusing on what makes a quadratic a quadratic. So let's talk about these basic equations. So these are all quadratic relations. And the things that make them all quadratic relations is this. I'm going to highlight it in yellow. You'll notice I got an x squared, I got an x squared, and I got another x squared in here. What makes these quadratic relations? For the equation, you're going to write for the equation to be quadratic. Equation, let's call it an equation / relationship to be quadratic. Comma, there is an x squared term. Now, I'm only going to say that this is the highest powered term. And that's all you need to recognize. The moment that you have an x squared term as the biggest number in R, as the biggest power for our terms in our equation, you know that it is an exponential. So for example, if I was looking at this, y is equal to x squared, that is a quadratic. And then maybe I looked at y is equal to -2x squared plus 3. Guess what? That is also a quadratic because it has an x squared term in it. So now, here we have these possible tables of values, okay? They're great. We don't like tables of values sometimes, right? So when we're working with tables of values, we have certain things that we have to consider. We have to consider what happens when we take our first difference. Okay, so remember last time we took a look at our first differences. So let's take a look at, let's call this example 1, example 2, and example 3. Here's example 1, here's example 2, and here is example 3. So what I'm going to do is I'm going to calculate example 1 and show you what happens with this. So for example 1, let's just copy that information down here. Okay. So last time when we were taking a look at lines, we actually took a look at doing the first and second differences, right? The first differences. So when we did our first difference, we actually took the top minus the bottom minus the top. So we did -2 and then subtract -7. In this case, I get 5. I do the same again. I get 1 for this minus -2, and I get, well, 3. And then I do the same again. Now, you take 2 minus 1 this time, and you get, you guessed it, 1. So now, if I was looking at this, this is what I would call the first difference. So my first difference for this first part doesn't really work out. So in math, we say, all right, if the first difference works, we're going to do a second difference. So if we do a second difference based on what we just calculated, we got something like this. Well, we got 3 minus 5. What do you get? -2. Wait a second. And then I've got 1 minus 3. Oh my gosh, that's also -2. Now, this is a quadratic because the second differences are the same. So that is what makes a table of values tell you that it is a quadratic. And in this case, example 1 is a quadratic. So take a moment, copy that down, and then we'll do the same thing for example 2. And we'll see if it is a linear or it is quadratic. Okay? And then if it doesn't work, we could say it's neither. All right, so now what I'm going to do is I'm going to do this problem over again, but this time we're going to do first and second differences for example 2. So now let's investigate by doing the first and second differences of this. So we start by doing our first differences to see if the first set of information is linear. If it is linear, we just stop there. Okay, so let's go 3 minus 0 gives us, well, 3. And we'll do this again. 8 minus 3 equals 5. Okay, and then bottom minus top again. 15 minus 8 is 7. Okay, so I could tell you right away that this is not linear. If it was linear, we could have stopped here. We could have said, okay, our information is linear, right? Now, let's say we have let's go and take a look at the second difference, okay? Because I kind of see there might be a relationship for the second differences because each of these differ by 2. So let's do that and show it. So now we take 5 minus 3 and we end up with 2. We take 7 minus 5 and we end up with 2. Oh my gosh, this is a quadratic. And the reason why it's a quadratic is because the second differences are 2, i.e. they are all the same, okay? Or you could say all the same. And there we have it. So remember, when you have a quadratic in a table, when you have something in a table and you're trying to find out whether it is linear or quadratic, you go through, you do your first differences. If your first differences come out to be linear, then you stop. Then if that doesn't work, then you check your second differences and then you stop. Okay? So there we go. There you have it. This example 2 is a linear, is quadratic actually. All right, so make sure you pause this because I'm about to go and delete all this and then do this once again for part 3. All right, so now let's do this once more for example 3. Now, for example 3, we're going to do our first and second differences like before. All right, so let's just do the first difference to just test. So for my first differences, right, I'm going to subtract the bottom minus the top. So ready? 0 minus 1 gives us -1. And then we go -3 minus 0 gives us, well, -3. And then we take -8 minus -3. You'll notice I put brackets around the negative. Okay, so I always put brackets around the second negative so that it reminds me that I have to use my brackets on my calculator. Okay, so now I've got -8 minus -3 gives us -5. So it looks like there is a difference of about 2 between each of these, right? So let's just go and verify this. Now, you would say that this is not a linear relationship, but you might be able to prove to me that it's quadratic. So then you go, okay, so quadratic. So we're going to do the second differences. Now, the reason why we're doing the second differences is to find whether something is quadratic or not. So here we go. So we go -3, and then notice the bracket of the second number, -1. I always do that. If there is a negative, I always put in a negative, put it in a bracket. So we end up with -2. We do it again. -5 minus -3 gives us -2. Excellent. So this is quadratic. So this table of values is quadratic. Can't spell. And this is because the second differences are the same. And we're done. That's it. And that's the work that we're doing today in class. We're looking to see if information is quadratic by taking a look at its second differences. You'll also be looking at graphs, identifying things like the vertex, which is a point, and we're done. All right, so for this problem, I'm going to give you a bunch of practice problems, not too much, a very easy set. And then what I want you to do is I'm going to give you an assignment which you will hand in for marks that will allow me to see if you understand this material, possibly. Make sure you hand it in before lunchtime. If you finish early, we have the next lesson ready to go, lesson 2 for today, and then possibly lesson 3. So when you think you've got the hang of the practice, go straight to the assignment and then start working on those practice problems on that assignment for me. I'm going to use that as an assignment mark based on the material that we're doing just now. And you know what? I'm not going to test you on this later. This is your testing.